Now let's take a look at the actual distribution code in the file called server.c. Now keep in mind that this file is pretty large this week. It's over 1,000 lines of code, but most of those lines we have written, and what we've left is a few blanks that you'll need to fill in to add some of the most compelling features of the web server to actually get it started. Indeed, if you run the distribution code after compiling it, you'll find that the web server doesn't do all that much. Instead, the user gets a 501 not implemented error message, but that should make sense because we've indeed not implemented all of its functionality. So let's take a look at server.c. And you'll want to go over this in a little more detail, a little more slowly at your own pace. But for now, let me try to guide you through it to give you a sense of what's useful to know, what's less useful to know, so that you can guide your own exploration. So at the top of server.c, of course, we have a whole bunch of defines as well as a whole bunch of includes. Worth noting is that we have a few global constants here, which we use in our code to make sure that certain arrays are of sufficient length based on how long the HTTP requests we expect to be receiving potentially from web clients or browsers. Meanwhile, let's scroll on down here to one type definition. Notice that just like in pset4, whereby we played with file I/O, similarly here we're playing with a lot of bytes, and so we've typed def_char to be a byte. In other words, the data type, capital B-Y-T-E, doesn't exist by default in C, so we've created it as a synonym for char so that we have some 8-bit value with which to work. Now there's a whole bunch of prototypes here, a few of which are for functions you'll write, but most of them we've written ourselves. Let's scroll down now to finally just a few global variables. One is this char star, aka root. Indeed, you'll notice we're not using the CS50 library anymore, so we're instead just using char star. And root is going to be a pointer to the string that represents the root of the server. So for instance, when I ran the command earlier and specified the root of public, that directory inside of the distribution code, root here would be a pointer to exactly that string, public, or really the full path /home/ubuntu/ so forth to that public directory. Meanwhile, in line 67 here, we have what are called file descriptors. These are similar in spirit to file star pointers, but it turns out there's another set of functions you can use with reading files or reading from network connections, like a web server, web browser connection, that actually just use integers instead of pointers like we saw in pset4. But it's the same idea, and I've made these global to keep track of a client file descriptor, like a pointer to my web client, and a server file descriptor, sort of a pointer to the web server, but they're not actually pointers, they're just numbers. Finally, we have this global variable here called signaled, which is my way, true or false, of keeping track of whether the user has signaled that he or she wants to stop the web server. And indeed, there's a function that listens for Control-C, so that if you, the user, want to kill the server by hitting Control-C, that Boolean variable you'll see in the code is set to true. And then within a loop, we keep checking the value of that variable. And if it's true, we just quit the program altogether. Let's now take a look at main. You don't need to understand everything in main, but let's give you a sense of the overall workflow and then take a closer look yourself at some of the comments. In the first place, partway through main, we parse the command line arguments. It turns out that main is going to expect either -h for help, which just tells you how to run the program very succinctly, or -p, which lets you specify a port, but again, using the port 8080 by default is what you should use in CS50 IDE. Next, we just do some error checking, making sure that the port value is indeed as we expect within a particular range. And then some of the magic starts. We call this function start, which we wrote. We pass into it the port as well as any optional arguments in order to start the server, specifically that port number. All right, next, this is fairly cryptic code that you won't see too often, but it's a fancy way of telling the program to listen for a signal being something like a special keystroke like Control-C. So this code here is how we register what's called an event listener, whereby anytime the user hits Control-C, that code tells the computer to run a function called handler, which is written lower down, implemented lower down in this file, server.c, that stops the program altogether. But no need to worry about the inner details there. Let's now focus on the inner loop. Indeed, what the web server is doing is deliberately looping infinitely. Because after all, that's pretty much what you want a web server to do. Until you explicitly stop it, you just want it to be sitting there effectively in a loop, waiting for someone on the internet to connect to it so that the web server can then respond to some request. Now notice at the top of the program, I free some variables because later on you'll see we're using malloc in some places. So I just want to make sure all of my variables are initialized to some known values. Down here I check whether the program has been signaled. In other words, if the user hit Control-C, let's just quit out of this loop by calling stop. And then now this code gets a little more interesting. But notice that you don't have to write anything in main. Rather, inside of main, we do the following. If the user has connected, this is a function we wrote that returns true or false, and every time it's called, it just says, yes, a client, a browser has connected to the server, or no, it has not. And in this way, can we just loop infinitely, waiting for true to be returned by that function. Meanwhile, this next function, request, we also wrote for you. This takes whatever is inside of that virtual envelope, the so-called HTTP request, and it actually parses it, so to speak, looking at it top to bottom, left to right, and loads all of those initial lines, like the get line and anything else below it, into a variable that we've called message for an HTTP message, and we've also loaded its length into length. Now, this is a bit different, so let's take a quick look at this. Even though you don't have to implement request, it's helpful perhaps to understand how it works. This function request apparently is taking in two arguments, message and length, but notice that I'm passing in an ampersand to both message and length. But if we scroll up, what are message and length? Well, notice that message and length are declared inside of main to be a char star and a size t, which is really just an int, respectively. So what's curious here, though, is that if message is a char star, but I'm passing in ampersand of message, that's kind of like getting the address of a pointer, a double pointer, if you will. And in fact, if I scroll on down, way down into this file, where request is actually implemented, I'm going to see the following signature or prototype for this function, which you've probably not seen before. The request function returns a bool. That's probably familiar. But notice its first argument. It's called message, but I could have called it anything here. But it's a char star star. And this is kind of a neat thing. Because I want this function request to allocate memory for however big the HTTP request is in that virtual envelope that it receives from the browser, I want to be able to return a string, but I also want to be able to return a length. So as you'll see in the specification, C, of course, cannot return multiple values. And in fact, I'm only returning a bool here. But just like we saw in lecture a while back, you can kind of sort of return two values if you pass in two values by reference or by pointer, so that you can actually go to those addresses, put values there, and effectively via this back channel, so to speak, can a function return multiple values to the caller. In this case, request can kind of sort of return three values. Its actual return type, a bool, the message, a char star star, and length, a size t, which is just an int, because this function request can go to the address length and put a value there, and it can go to the address of message and put a value there. And that now should make sense, because even though message is a char star star, as soon as you go there with star message, as we've seen before in code, what are you going to find? You're going to find waiting for you there a chunk of memory that should be a char star or the address of a string. And it's okay if you don't quite wrap your mind around that too quickly, but consider that all we're doing is taking the address of a pointer so that we can go there and actually put a pointer there. But not to worry if that doesn't quite sink in just now. Know for now that the request function effectively provides you with those three values. So let's now go back to main. What's going on next in main is the following. Once I have gotten inside of message and length, the two values I care about, then we go ahead and write some code for you that allows you to read just the first line, the so-called request line from the request, specifically something like get/HTTP 1.1 and nothing more. So there's a whole bunch of other HTTP headers, recall, that a browser sends from a client to a server. We're just ignoring all of those so that all you see on the terminal window, recall, is just something like get/hello.html HTTP/1.1. So notice, though, that these tricks we're doing here are going to be useful perhaps in your own parse function, which we will implement. Notice how that I'm just declaring a variable, happens to be const, which means I promise not to change this, called haystack. Then I cleverly name my next variable needle so that I can sort of proverbially look for a needle in a haystack using a super handy function called str, str, which per its man page, or per reference.cs50.net, allows you to search for one string and another. And this is my way of searching for the end of a line so that I can actually read just one line into memory. Meanwhile, notice on line 176 here, I actually allocate enough memory for that line, and then using str ncopy and using just array bracket notation, do I store in that array exactly that first line. In fact, let me just jump over quickly to the specification for problem set 6. Do read through this in detail, but what you will find is this particular line here, whereby based on the specification, the formal definition of HTTP, we specify what the very first line should be from any browser to a server inside of that so-called virtual envelope. Specifically, the browser should mention a method like a get or post or the like, then literally a space represented here with just SP so that it's explicit lit. We really want a space here. Then request target, which will be something like /hello.html, followed by another space, followed by a version, which would be something like HTTP/1.1, followed by CRLF, which is an acronym you're going to see a lot in the specification. And this is just a fancy way of saying \R\n. In other words, carriage return, new line, or line feed. Carriage return, line feed. That's what CRLF means. Now, meanwhile, if we go back to our code, let's see what remains for you to do. Inside of main, finally, there's a call to a parse function. The purpose of parse is to take that very first line, whose definition we just saw in the specification, and extract the so-called absolute path and query. Now, take a look at the spec for what we mean by that. But in long story short, this thing here, request target, is a string that can be broken up into two parts, or an absolute path like /hello.html, followed by an optional question mark, and then something like q equals cats, or q equals dogs, or any number of key value pairs that we saw in lecture being part of the parameterization of an HTTP request. So what you're going to need to do is implement parse and figure out how to iterate over line, which is just the first argument that we're passing in, character for character for character, only going up to the end of that string, looking for that absolute path and looking for that query. And what's nice about the fact that we've given you in the documentation this grammatical definition of that first line, here you're going to have to figure out, well, what is the method? Is it valid or not? And we tell you in the spec when it is or isn't valid. Get, for instance, will be valid. Space will be easy to check for, just using week 2 style or problem set 2 style string checking or character checking. Request target is the thing you're going to want to parse, so take a look at the spec for what's expected there. And then lastly, HTTP version, you just want to make sure it's among the supported versions like HTTP 1.1. So essentially, your parse function is going to be an opportunity to just read this thing character for character for character, or string by string, making sure that it matches this specification. All right, back to main. Let's see what remains. So suppose you've now implemented your parse function. We've parsed out from it the so-called absolute path and the query. What does main now have to do with this? Well, one, you'll see in the code that we URL decoded. In case the browser has encoded certain special characters in a special way, we go ahead and convert those back to the appropriate ASCII characters. Then we go ahead and figure out if the user has requested /hello.html, what file do they really mean? In other words, we need to take the root of the server, that path to the public directory, and concatenate it with something like hello.html so that we have one bigger string that leads us exactly to the actual hello.html file on CS50 IDE's hard drive or disk. Next, we check that the path actually exists. Otherwise, we throw a 404 error for the user. And in fact, throughout our code, you'll see a lot of uses of this error function, which we ourselves wrote, and the specification walks you through. This is just a way of returning something other than 200 to the user. Now down here, I go ahead and figure out, is what the user has requested a file or a directory? Because if it's a directory, I want to do a couple of things. One, if the user visits a URL, like if the user visits a URL that is for a directory but does not end in a slash, for conventional reasons, I want to make sure that we change the URL to actually end in a slash. And so you'll see in the source code that we've given you, we force the user to redirect to not foo, but foo/, if they've done that, and see the specification accordingly. Meanwhile, we check one other thing. If the user has visited a directory, and that directory contains a file called index.html or index.php, by human convention, we don't want to show them the contents of that directory. We want to show them the contents of that default file, index.html or index.php. And so the code I've highlighted here calls a function called indexes that simply checks, does there exist a file in here called index.html or index.php? Otherwise, if none of those conditions apply, we simply call a function list, which we wrote, which literally lists the contents of a directory. All right, and what if the request that the user's browser has made is not for a directory, but for a file? Well, first, we call a lookup function, which is going to tell the server, is this a JPEG? Is this an HTML file? Is this a GIF or some other format? If so, it's then going to check, well, is it a PHP file? If so, we want to call a function called interpret that we wrote that interprets that PHP file and spits out the results, or more compellingly, finally, if it's anything else, let's go ahead and just transfer the file, like the GIF or the JPEG, from the server to the user as though they requested an HTML page, an image, or any number of other things. Finally, if nothing else seems to work, we're just going to say 501, which is that 501 not implemented message, meaning the server is not yet complete.